In this video, we're going to extend it to looking at Quartics. So we've had a very brief introduction of what Quartics look like, and we can use much of the same concepts that we used with cubics in order to sketch them. So for this first one, we've got y is equal to x times x minus 1 times x minus 2 times x minus 3. So what that's telling me is that we have a quartic that is passing through x, 1, 2, and 3. Okay? Now, before we go any further, we need to understand what a quartic in general looks like. Now, a quartic, if you go back to just y is equal to x to the 4, y equals x to the 4 looks like this. So it's kind of got quite a flat bottom. Redraw that. It's kind of got quite a flat bottom, kind of like a quadratic from afar, but it's got a flatter bottom and it's got steeper edges. Okay, so the main point to take away from this is that because x we've got to the power of 4, when we substitute in a negative number, we get a positive number. So minus 1 to the power of 4, for example, is 1. So it's starting in the very top left and works its way through and then ends up in the top right. Okay? That's for a positive coefficient of x to the 4. If it is negative, then we would have a situation that looks something like this. Okay, so this is y is equal to minus x to the 4, starting in the bottom left and ending in the bottom right. So if the coefficient of the quartic, the quartic term, is positive, we'll be starting in top left and ending in top right. For a negative coefficient of x to the 4, start in bottom left, end in bottom right. Okay? So we're going to use that information in order to deal with these curves. So we've got for this one, we must be starting in the top left, because if I expanded all those brackets out, I would get a positive x to the 4. So we must be starting in the top left. And if we're doing that, we must first be going through that 0, 0, then back round and through 1, then 2, then 3, and then shooting off into the top right. So starting in the top left, ending in the top right. So 0, 1, 2, and 3. Now, as for the scale of what's happening here, okay, that's a little bit less clear. We would have to do a little bit more digging, a little bit more with differentiation in order to look at the stationary points in order to find where they are, where those turning points are. So we will learn skills that will enable us to identify where those points are. We'll be looking at that later. Okay, and therefore we'll be able to look at a little bit of the scale of these curves. So number 2, we've got y is equal to x plus 2, x plus 1, x minus 2, x minus 3. Okay, so we've got a curve that's going through minus 2, minus 1, 2, and 3. And of course, because if I multiplied this out, I'd get a positive x to the 4, I must be starting in the top left. So our curve must start in the top left, go through this point, back round through here. Now it would have to do something like that in order to go back round and hit those 2 points and shoot off to the top right. So starting top left, ending in top right. So we've got minus 2, minus 1, 2, and 3. And of course for this one we could identify where it's crossing the y-axis. So we can work with the brackets in exactly the same way as we did for cubics, multiplying the individual numbers by themselves. So 2 times 1 times minus 2 times minus 3 will get minus 4, a positive 12. Okay, and that's a sketch of number 2. So let's have a look at number 3. We've got y is equal to 2x minus 1, 2x minus 3, x minus 4, and x plus 1. Okay, so we've got, let's put in these two first. We've got minus 1 and 4. We've got a half and 3 halves. So a half and 3 halves. So we must have something like this. Shooting off like that. So we've got the minus 1, we've got the half, and we've got the 3 halves, and we've got the 4. Okay? We could identify where it's crossing the y-axis by multiplying minus 1 by minus 3 by minus 4 by 1. And so we would have minus 12. Okay? And that's number 3. So with number 4, we've got a curve that's going to be touching 1, 2, and 3 on the x-axis. Now clearly something is going to be happening with this x minus 3 squared, this repeated factor, much like it did for a quadratic or a cubic. So we've got to also start in the top left-hand side of the graph, because we're going to have a positive x to the 4 when we expand out those brackets. So we've got to start up here, and the curve's going to come through, cross through that point, and then back through this one. Okay, now if we pause there, we also know that the curve's got to end up in the top right. So that means that this curve, in order to do that, has to come around and brush that point just on the x-axis. Now that is where our repeated root is. So much as it would have done in the case of a cubic or a quadratic, the curve just brushes the x-axis at that point. Now we can also identify where it's crossing the y-axis by multiplying minus 1 by minus 2 by minus 3 by minus 3. Okay, so you've still got 2 minus 3's there. So that would be 9 times minus 2 is minus 18 times minus 1 is positive 18. Okay, and that is the curve. Okay, so number 5, we've got y is equal to x squared times x minus 1 squared. Now, seeing as the curve is only touching the x-axis at 2 points here, we've got 0 and 1. The curve must start on the top left, okay? So it must come down and hit that point. Now, we've got to be a little bit careful here, okay? Because ultimately, the curve doesn't just go through that point and then go through that one, okay? Now, the reason as to why it doesn't do that is because of the repeated root nature that we have here. So you could trial a point that is halfway between 0 and 1. So let's say a half, okay? I said halfway, but you didn't have to choose one halfway, but a half will do. So if I substitute a half into this, do I get something that is negative? Okay, so that would mean that the curve is going below the x-axis. But if I substitute in a half, I get a half squared, which is a quarter. A half take away 1 is minus a half. A minus a half squared is a quarter. So I get a quarter times a quarter, which is a 16th. So I get something that's positive. So between these 2 points, we cannot go below the x-axis because this will be positive. So, in order for the curve to come down and not cross through the x-axis, it must be a local minimum. So it must just brush the x-axis at that point. And then it must come back on itself to brush the x-axis at this point as well. because in fact, regardless of the value of x I substitute in, I will always have a number that is greater than or equal to 0. So it will never go below the x-axis. So it must be at 0 and 1, and the curve would have to look something like this. Okay. Let's have a look at number 6. We've got 2 minus x times x plus 4 times x squared minus 1. Now, obviously, spotting that x squared minus 1 is the difference of two squares. We can rewrite it like that. So, we're crossing through at 2, minus 4, 1, and minus 1. Okay? Now, if I expand these brackets out, I'm going to get a minus x to the 4. So I must be starting in the bottom left and ending in the bottom right. So I must be going through this point, through that one. Oh, missed that one. There we are. And back down and through. Okay, so something like that. So we're hitting the x-axis at 2, 1, minus 1, and minus 4. And we can identify where it's crossing the y-axis by multiplying 2 by 4 by minus 1 by 1. And that would be minus 8. Now, I've drawn the vertex here on the y-axis. Now, that's not necessarily quite right. We would have to do a little bit more digging, a little bit more investigative work in order to identify exactly where that point is. We would have to use differentiation to find the stationary points to identify exactly which side of the y-axis it is if it doesn't sit on the y-axis itself. Okay, so that one could require a little bit more investigation. Number 7, we've got y is equal to 1 minus x times x minus 5 times x minus 6 times x plus 2. So we have a curve crossing at 1, 5, 6, and minus 2. So something like that. And if I expanded these brackets out, I'd get a minus x squared, minus x to the 4, sorry. So we must be starting in the bottom left. So this curve must look something like this. So here's my minus 2, there's 1, there's 5, and there's 6. And we can identify where it's crossing the y-axis by multiplying 1 by minus 5 by minus 6 by 2. So that would be 60. Okay, and that's number 7. Right, number 8, we have y is equal to 3 minus x, 2 minus x, 1 minus x, 3x plus 2. Okay, so we've got a curve going through 1, 2, and 3, and minus 2/3. So something like that. Okay. Now, if I expanded these brackets out, I have a minus x times a minus x times a minus x times a 3x. So that would be minus 3x to the 4. So we're starting in the bottom left. So we have a curve that must look something like that. Okay, so we have 1, 2, and 3, and this is minus 2/3. And crossing through the y-axis at 3 times 2 times 1 times 2, so that would be 12. Okay, so that's number 8. Now, number 9, we've got y is equal to x cubed times x minus 1. So I actually only know 2 points as to where it's crossing the x-axis, 0 and 1. Okay? Now, if I expanded this out, I would have to have a positive x to the 4. Okay? So, I need to think about exactly how this curve is going to work. So, from the right-hand side, it must be coming in this way, and from the left-hand side, it must be coming in this way. Okay? However, I must think about what's happening between 0 and 1 in a similar way to how I thought about what was happening up here in number 5. So if I just try x as a half, we have a half cubed, which is an eighth, times a half take away 1. So we get half take away 1 is minus a half times an eighth is minus a 16th. So we have something that's negative. So we definitely go below the x-axis between 0 and 1. In fact, that bracket will be negative. Okay, so we know that that happens. Now, what happens at this point, because we've got this x cubed, okay? Well, we've got to think a little bit carefully about this, because if I expanded this out, I'd have x to the 4 minus x cubed. Now, what's happening at this point we could use some differentiation to really look at the type of curve that I would be getting around that point, to really define its shape. When we're close to 0, okay, when we're quite close to 0, this x to the 4 will be, well, won't really count for much, okay? This will overpower the x to the 4. So this curve close to 0 is going to look more like minus x cubed than it will x to the 4. So minus x cubed is a curve that looks like this. Okay? And it has this point of inflection at 0. And this curve does too. So there is a point of inflection at 0 because of how this curve behaves. So we've got this going below the x-axis, then going back round through that point and up like so. Okay? Now, how I've explained that point of inflection coming about, it is because of how this x cubed, this minus x cubed, will overpower this x to the 4. So this curve will behave more like that, close to 0. Okay? Because obviously that will be much smaller than that. However, in order to really have a look at it and to really understand it, it is a good idea to look at that one once you've learnt how to find stationary points, how to look at points of inflection using differentiation. Okay? So we can bring those skills together. Right, and last but not least, we have y is equal to x minus 1 to the 4. So all we know from this one is that it is going through 1 on the x-axis. Now we know what y equals x to the 4 looks like. It looks like a curve that has a flat bottom and has quite steep sides. And if I've just replaced x with x minus 1, that's just translated it 1 to the right. So actually, this is the translated curve of y equals x to the 4. Like so. So when x is 0, I get minus 1 to the power of 4, which is just 1. And so this curve goes through 1 on the y-axis, okay? So as you can see, we can use our knowledge of cubics to extend our understanding to Quartics. Now, obviously, there are things that we're not quite seeing at this point. We're not quite able to identify where the vertices are, where the turning points are, because we need the differentiation skills to do that. So once you've got those skills, it'd be worthwhile coming back to these curves and being able to fully sketch them and identify all of the points that you can.